All right, hello all the people that are gone. We are doing a little break kind of today. We're not doing a chapter or a section of the chapter. We are doing this cheat sheet. So this, you can do this yourself and just use a piece of paper and write all this information down. You just need it separated into 4 pieces. So it's like folded half and folded half, like hot dog and hamburger style. And multiplying probabilities we're going to do on the top and adding probabilities that we're going to do on the bottom. Okay, good? So this is like 4 sections to this piece of paper, okay? We just got done with 12.4. We took a quiz over 12.1 through 12.4. 12.5 has to do with adding probabilities. Don't write that down. 12.6, I'm going to erase it. 12.6 has to do with multiplying probabilities. Now, when you do 12.5, it's going to be very easy for you because you'll know that, oh, hey, I need to be adding these fractions together every time. And then when we do 12.6, it's going to be very easy for you because you're like, okay, I know that I have to multiply these probabilities together. But then when we come to the review for this chapter and they're all shoved together, you're like, oh crap, when do I multiply and when do I add? Am I supposed to multiply or add here? And when you get to the test, you're like, oh crap, am I supposed to multiply or add here, right? So this is your cheat sheet that kind of is like a look-see into the next 2 sections that will tell you how you know which one to do and where. Got it? Before we get to that, do you guys know your cards? Yep. Okay, if you don't know your cards, add this on the back side, okay? Your cards, we don't go off of jokers, so when they ask you for card questions on your homework assignment, which you won't have any homework today, but if they ask you for homework stuff, there are 52 cards in a deck, 54 with jokers, but we assume that you're not doing jokers. That's how they assume in this chapter, right? We're assuming no jokers, 52 cards total. They are ace through king, ace through 10 and jack, queen, king. That's 13 cards for each like suit, right? How many suits are there? 4 suits. They are heart, diamond. I always have to think. This is a spade. This is a club. Okay. It's the shovel and the puppy feet. Okay. I have to think about it. I don't know why. 4 suits. 2 are red, 2 are black, right? So half of the deck, there's 26 cards that are red, 26 cards that are black, 13 in each suit. Do you see how this works? So you have like the ace of hearts, you have the ace of diamonds, you have the ace of spades, the ace of clubs, then you have the 2 of each one, and the 3 of each one, and the 4 of each one, right? We know how this works, right? Yep. Okay, so suits versus like each number, 52 all together. Got it? Okay, we know how this works. All right, so draw yourself a little grid if you need to. You don't have to fill them all in, but like at least do your headings and stuff, okay? So when they have that stuff, there it is. Got it? Okay, all right. They make us, let's multiply first. Let's talk multiplying first, even though I think this is section 12.6, but we'll multiply first. So here are your 2 examples, okay? There are 2 different scenarios that are going to require you to multiply, and we're going to talk about when you multiply versus add. But here are your 2 examples. The first one says, you are drawing 2 cards. I want to know the probability that you draw a 7 and then a king with replacement. So after you draw the 7, you put that card back in, and then you're drawing a king, right? I'm replacing the first card. Have you heard that before? Replace and not replace. Maybe you've seen that on maps testing, okay? So copy that example down in this first box. Leave a little bit of room up here at the top because I'm going to write up here, so just a tad bit of room, okay? If you can. Well, that's fine, whatever then, okay? Just as long as you have we'll just put it in a different spot. It's fine, whatever, okay? You don't need that much room, but whatever, okay? The next example is the same thing. Draw the probability, or you're drawing 2 cards. I want to find the probability of drawing a 7 and then a king, which is exactly what I was doing before. But this time I am not replacing. So after I draw the 7, I keep that card and then I draw a king, right? And there is a little bit of a difference. Yeah, you have to do 51 cards instead of 52, okay? So there's your stuff. Colton, write this down. Put that away. Okay, we're going to fill in both of these examples, and I'm going to tell you why you know that you should be multiplying these fractions together, okay?
Find probability of 7.
Of drawing a 7 and then drawing a king. I really paraphrase, so like if you want to write the whole words out, that's fine.
Nope.
Drawing a 7 and then a king. With replace, without replace. Okay, maybe I'll underline that. With replace, without replace. This is like your little cheat sheet. This is how you know when to do what, okay?
Why does my red kind of look like my orange?
Okay, are we ready to answer these questions?
No.
Okay. There are two things that tell me I need to multiply these to solve these things. How do I know that I need to be multiplying? Drawing what? Cards. What? You are drawing, I'm going to say two, put a star here, 2 or more events. So I am drawing 2 cards. I'm not just drawing one, I'm drawing 2 cards, right? And doing 2 things requires me to multiply. There is another key word that you will see, kind of, sometimes, and it is this one. And then, right? Sometimes it will just see then, but that just means and then. And means you're doing 2 or more things, right? So if you see any one of those things happen, if you know that you're doing 2 or more events, right? I'm drawing 2 cards. Or you see the words and, guess what? You remember before when we would do this? This is and, right? Okay, this is when we're multiplying. So this is the intersection. And this is when we multiply. All right, here's the deal. We've got 2 things happening. The first thing on example 1 that I'm wanting to do is I want to draw a 7. What's the probability of me drawing a 7 out of a deck of cards?
4 and 52.
4 out of 52. There's 4 7s out of 52, right? Okay? And I want to multiply that by the probability of drawing a king. Now, after I drew the 7, I am now putting it back in the deck. So how many total cards do I have? Still 52. And how many of those are kings? 4 out of 52. Now, if we're going to multiply, I highly suggest you reduce this stuff beforehand. Like 4 and 52 will reduce really nicely. If I divide by 4, 4 divided by 4 is 1. 52 divided by 4 is 13. And this is 1 and 13 as well. And then I just multiply the tops together. 1 and 13 times 13 is 169. So 1 out of 169 is the probability that happens exactly. A 7 and then a king when I put it back in the deck. Okay? Now, how does that change in the second example? I'm still drawing a 7 and I'm still drawing a king. The chances of me drawing a 7 is 4 out of 52. But I've drawn that 7. And when we're doing this, we assume that the card that we were wanting to draw, which was a 7, was the card I did in fact draw, right?
5 out of 51?
So I now only have 51 cards, but how many of them are kings?
4.
Still 4, right? But now I only have 51 cards, okay? So I can still reduce this one to be 1 over 13. 4 and 51 won't reduce, right? So I just multiply across. 1 times 4 is 4. 13 times 51, 663? Yeah. 4 over 663.
What?
Do that.
Because I'm just so
I
smart.
looked away for like a minute.
She's ginger. She's a bitch.
Are you writing this down? You haven't written anything on your
No.
paper yet.
Simon.
You haven't written anything.
This is
This
all
is
we're doing today.
this is all on the
The
top.
words?
Yes, you
You
need
have to
all of
do all
this.
of that.
You need to put all of this down on your paper.
Oh, yeah, 'cause, like,
Okay.
you naughty kid. I looked
Okay.
away for like a minute.
Obviously, we've been doing this for longer than a minute.
All right, now, if both of these are multiplying, what's the difference between the left one and the right one?
The right one, you don't put the card back.
Yeah, the right one, you don't put the card back, okay? They call those independent and dependent events. So which one is dependent?
The right.
Then without replace, the right one. This is dependent because dependent, put a little star there. Those are multiplying, but that's with dependent events. The second card depends on the first card because I only have 51 cards the second time, right? So that means this one is independent.
Why are they grabbing guys?
Okay? Independent versus dependent. That's the categorization between the two, right? We're still multiplying, but independent versus dependent. Got it? And now let's add.
No.
Usually like banging on the
And now let's add. We only have one more thing left. Just the adding part.
Just need
Okay?
a yes or no.
Yeah.
It's a no.
Pale blue.
Pale blue?
Yeah.
Like
As
this top right
yeah,
here?
for like a little accent of color. Because if I put everything yellow, it looks bad. Do we like? Do we not like?
Yeah, Jacob.
I look good.
More
Yeah.
pale. I don't know.
Do I look like the wall?
I like it. I
I
like
like
it.
it too.
I like it. I like it. I think I like it. Or you could do, well, no, because you're doing gold, not silver. I don't know. I like it. I like it. I like
literally
it.
was
I like it.
Googling colors.
Sure. Color schemes. Yeah, I like it. I think I like it.
We'll see what Hallie thinks.
I think I like it. Okay. All right. Now let's add. Okay. Here are your two examples that you need to add for adding. Okay. Here I'm drawing a card, and I want to know the probability of a 7 or a king. Colton, write this down. I am drawing a card. Find the probability of a 7 or a king. Then the right one is draw a card. Find the probability of 7 or a heart. Okay. Here we go. 7 or a king, and then a 7 or a heart. Okay. If you haven't figured this out yet, this is the notation that they'll use when they're doing symbols, right? This just means find the probability of that thing happening. They just do P, right? P and then parentheses. That means the same thing. So if they ever do that to you, that's what they're asking for. Both of these scenarios require us to add the fractions together.
Yeah.
Okay.
So I wonder if, so we're doing, so it would be the same thing though for each, right? The same.
Maybe. Maybe. We'll see. Just wait. Just wait. We'll get to that.
Oh, the heart. It's a category. It's not a single clue.
Right. All right, did you get these written down?
Yes.
Okay, how do I know I need to add?
It's not.
Or is the key word. Okay? Which means when it says or,
You add.
I'm not doing more than one. I'm only doing one event. Okay? I'm only drawing a card. I'm only drawing one card. Now I have two categories. I want to know 7 or a king, but I only have a card. I only have one event happening, right? That means I have to add those probabilities together. What?
Where do you want this? Take it out to your car.
You can take it to my car. That would be awesome. Do you know where my car is? Yeah? Okay, cool.
Pull it up for them.
Okay, so one event, and you see the words or, right? That means you add. You see those words or, you add. Okay? Now, there's a difference between this one and this one. We'll get to that. Let's solve the left one. Okay? I want to know the probability of a 7 or a king. I know I'm going to add those fractions together. What's the probability of getting a 7?
7.
4 out of 52. What's the chances of getting a king? 4 out of 52. Now, here is when I would not reduce. Okay? I would not reduce. I would not reduce until the very end because you might end up reducing and then end up getting non-common denominators. To add, you have to have a common denominator, which I do right now. So let's go ahead and add these together. 4 plus 4 is 8 over...
52.
Yeah, the bottom number stays 52. It does not become 104, right? Okay. Now I can divide by 4, which is 2/13. Awesome. 2 over 13 is the chances of that happening. Okay. Now, what's the problem with the right one?
So there's 13 hearts. There's 13 hearts. There's 13 hearts.
Yeah. You're all right, right? So there's 4 sevens, which is 4 out of 52. How many hearts are there?
13 out of 52.
13 out of 52. Okay? Now here's the problem. If I draw like a Venn diagram and here's all my sevens, there's 4 sevens. There are, these are hearts. There are 13 hearts, but there is one card that is counted twice, right? A 7 can also be a heart, right? You can have the 7 of hearts. You can have a card that's a 7 and a heart at the same time. So I have counted the 7 of hearts over here, and I've counted the 7 of hearts over here, which means I have one card that's double counted, right?
Yeah.
So how do I do that then?
Take one off.
I'm going to subtract 1 so that it's only counted once, right? So the way that I do this is I add the two outsides of my Venn diagram and I subtract out the middle, right? The one card that's overlapped.
Do that regularly.
I mean, you can, probably, right? You can.
4/13.
Okay? And 4 plus 13 minus 1 is
17.
16 over 52. And if I divide by 4, that is 4/13.
That was actually.
Okay, now hold on. Just like up above, we have independent and dependent. These have like subcategories. They are called inclusive and exclusive. Which one is inclusive?
Right.
The right one is inclusive because I have somebody that is included in both sides. So this is inclusive. Put a star. Inclusive. Okay? This is exclusive. Now, your book sometimes does some stupid things and they say not inclusive instead of exclusive. Whatever. Another thing that they will do also is instead of calling it inclusive, write this down. Instead of calling it inclusive, they will call them, actually, instead of calling them exclusive, they will call them disjoint. Meaning not joined together, right? They will call it disjoint. Okay?
That's okay.
They don't usually say joint. I don't know why they use these, right? Disjoint.
Just
If it's inclusive, it's inclusive. If it's the other one, they might say exclusive or disjoint or not inclusive. Whatever. Okay? All right. One more thing real quick. Let's talk an example in this class. Okay. Okay, as it applies to Blue Hill, how about this? As it applies to Blue Hill, we have basketball players in here?
Yep.
Yeah, we are.
Yeah. Let's talk basketball players. And then let's talk boys.
Oh.
Okay? Inclusive or exclusive?
You have a whole bunch of
Inclusive.
Inclusive. Okay, there are, I don't know, yeah, somewhere.
Found
Right
it.
here, right here. Okay?
Got groups.
All right, basketball. Who is basketball in here? We have 2, 4, 6, 8, 10, 12, 13 people in this room. So we'll just say out of 13, right? Okay? Out of 13. How many basketball? Raise your hands real high. 1, 2, 3.
Hey, 4.
That's it?
4.
4. 4.
That's it.
There's a lot more.
That's it?
Usually.
4 basketball. Okay? How many boys in here? All but 2. So that would be like 11, right? There's only 2 girls in here right now. Okay? And how many are overlapped?
Trace.
Really?
Me, Simon, Trevor.
You, Simon, Trevin, there's 3 of you? There's 3 of you that are overlapped, right? So here's how you know this is not right. Ready? If I am looking for a boy or a basketball player, right, it would be 4 over 13 plus 11 over 13, right? There's 4 basketball players and 11 boys. And if I add those together, hold on. If I add those together, that makes 15 over 13, which I know is wrong. How do I know that that's wrong? You can't have a number that's bigger than 1. 15 over 13 is a number bigger than 1. So I know that I have to subtract those 3 people out because those 3 people, Trevin, Simon, Jack, are overlapped, and thank God we don't have 2 of you.
Wow.
Right? We don't want 2 of each of those 3 boys.
Would be
So I have to subtract. So the final answer is going to be 12 out of 13. I have a 12 out of 13 chance of coming in this room, choosing a student, and then be either a basketball player or a boy. There is only 1 student in here that is not a basketball player or a boy, and it is
there's
There's 2.
3.
Jace is counted as a girl, right? Hallie is the only one in this room right now.
Wait, we're boys.
You guys are going.
Right. Oh, you weren't trying to make a joke. Okay, I thought you were trying to make a joke and say Jace is not a boy. He's just slow. He's not trying to be funny. Oh, shoot. So Hallie is the only one out of 13 that is not a basketball player or a boy, right? Okay? Because Sienna falls into the basketball player category. All the rest of you are either double counted or in the boy category. Does that make sense? Now, here's my question. Let's say we're talking about the whole school of Blue Hill, right? And we're talking about wrestlers or girls. Wrestler or girl. Inclusive or exclusive?
Exclusive.
Inclusive.
Inclusive, yeah, wrong one. I said wrong one.
Can you be a wrestler and a girl at the same time?
Yes.
Yes, but for Blue Hill, do we have any?
Yes.
We do? Okay, then that was a bad example. Okay, just because we don't have any, even if this number in here is 0, doesn't mean it couldn't be inclusive. Does that make sense? Okay, so let's say Blue Hill didn't have any girl wrestlers. Just because we don't have any doesn't mean you couldn't be, right? But we do have 3. Who are the 3?
Some weird kid.
Presley Ann?
Presley Ann.
I didn't know she was a wrestler. And Lillian Kent. And who else? You don't know?
Kaylee.
Who?
Kaylee Klein.
Kaylee Klein,
Lillian,
okay.
and Presley.
Okay, gotcha. Nice. Okay, there you go.
Kaylee's
So,
the weird one.
you're trying to figure out whether they overlap or not, okay? So, let's say your 2 categories are junior versus senior. Inclusive or exclusive?
Exclusive.
Exclusive, right? You cannot be a junior and a senior at the same time. I understand, like with college, sometimes you're a junior, but you're classified as a senior if you have that much credits. We're not talking about that. Juniors and seniors at the same time, you cannot happen. What?
Why not?
Why not? I don't know.
I
Whatever.
think high school should be like college, and not, instead of going for a certain amount of time, you go for a certain amount of credit.
I didn't even see the walk in.
That's true. What about wrestling versus basketball for high school?
No.
What about wrestling versus basketball for high school? Exclusive, right? What about wrestling versus basketball for junior high? Inclusive, because boys can wrestle and play basketball in junior high, right? Do we see how this works?
Yeah.
It counted, double counted versus not, can't be the same. Okay, there you go. So there's that sheet. Beautiful. That is going to be your cheat sheet for the next 2 sections.
That's not.
Okay, goodbye people watching this video.